Good afternoon, everyone. And I'm Xuan Ouyang from NWPU Hackers team. I will present our solution and results for the Northern Standstill Challenge 2025. Firstly, I'd like to introduce our multi-view registration method, which has two modules. The first is the global feature extraction module. We followed SGHR SOTA pipeline for multi-view point cloud registration. It first extracts key points and point level feature utilizing pre-trained UHO descriptor. The global feature of single scan is also extracted for represent overlapping similarity between scans. Since we noticed this challenge really late, about May the 7th, we didn't have enough time to directly train the feature extraction part on the NSS training set. Another reason is that we test SGHR on it shows, and it shows good generalization ability on ETH and ScanNet datasets. So we directly use the pre-trained weights to train on 3D match dataset. The backend is an iterative maximum click merging module. We replaced the backend of SGHR with this to enhance the global consistency. Our intention is to increase the overlap region between point clouds in order to improve the successful rate of pairwise registration. And there is some quantitative results shows a clear dichotomy. We got relatively good pairwise alignment, which achieved 0.68 right rotation error and 0.03 meters translation error, indicating relative higher precision in local point cloud transformation synchronization. However, the global metrics are suboptimal. The RMSE is larger and FE score is so low. So which suggests difficulties in unifying local clusters into global coordinate. I think this gap stems from two factors. The first one is inappropriate anchor scan. Although our method performed best in pairwise metrics, without selecting an appropriate anchor scan, errors accumulated in global coordinates, which cause large global RMSE. The second issue is the limitations of descriptor. UHO descriptor struggled with repetitive structures such as walls or corners, causing low registration recall in feature matching. More importantly, the extracted global features have lower discrimination, leading to unreliable sparse graph construction. Now let me show some qualitative results of pairwise registration. This is a successful registration case. The overlap region between source and target is big, so it is easier for both the pairwise registration module and the transformation synchronization backend. The calculated overlapping score is nearly the same with the score under JT. Another successful case, which has smaller overlapping region, the overlap score calculated using global feature similarity is much higher than the true overlapping score, which leads to unreliable sparse graph construction. This is the key issue of our method. And this is a failure case. The room intersects with the corridor with only a few overlapping areas of the ground and walls. But the two scans global features are similar, which leads wrong overlapping estimation. The method failed to remove the age, which is nearly impossible of pairwise registration. And here's some visualization for multi-view registration. This is a totally failure case because the geometric features of the corridor and the room are simple and repetitive, making it difficult to distinguish which age really overlaps. And another case, due to the high similarity, the small room above was wrongly aligned to the rooms below. And this is one of the corridor parts was mistakenly aligned to the room, and it's a common problem in our test. In conclusion, through the evaluation, we find two key limitations in our method. Firstly, the current implementation lacks strong global constraints and need an anchor scan selection mechanism, resulting in suboptimal performance on global evaluation metrics. The second issue is that while the sparse graph initialization module performs reliably on geometric-rich datasets like 3D Match, ETH, and ScanNet, it generalizes poorly to NSS datasets, leading to incorrect overlapping pair judgments. And looking ahead, we will focus on 3 key upgrades. First one is better anchor scan selection to boost global alignment. The second one is to model the temporal information using stage information. The third one is the semantic and geometric fusion, such as utilizing semantic scenes graphs to enhance the distinguishability of features. The fourth one is the global consistency loss to make the solution end-to-end. Until now, there are few end-to-end learning-based multi-waypoint registration solutions. And thank you for listening. And this is my email address. If you have any questions, please contact me.
Okay, thank you very much. So if you have any questions,